My name is Dr. Rudy Rosen, and I'm your instructor for Texas Aquatic Science and Introduction. I'm a research professor at the Meadows Center for Water and the Environment at Texas State University. I recently wrote the textbook, Texas Aquatic Science, in cooperation with Texas Parks and Wildlife Department and the Hart Research Institute for Gulf of Mexico Studies at Texas A&M University at Corpus Christi. Also contributing was the Missouri Department of Conservation. Funding for that work was provided by the U.S. Fish and Wildlife Service's Sportfish Restoration Program and the Ewing-Hossel Foundation, San Antonio. This lesson is adapted from that book. Production of this video, in part, was funded by a grant from the National Science Foundation. Today's lesson is an overview of aquatic ecosystems. Now, each ecosystem I describe in this lesson will be covered in greater detail in following lessons. To help focus today's lesson, here are a few questions to consider. What is an ecosystem? What are some of the parts of an ecosystem? How do the parts of an ecosystem interact with one another? What kinds of aquatic ecosystems do we have in Texas? How are they alike, or how are they different from one another? What is biodiversity? Why is biodiversity important? How do humans impact aquatic ecosystems? And how can we help conserve aquatic ecosystems? An additional question for discussion: how is the diversity of species in Texas's aquatic ecosystems connected to the economic well-being of Texas citizens? Let's get started. An ecosystem is a complex web of relationships between living and non-living things. The study of ecosystems is known as ecology. The biotic parts of an ecosystem are the living components, such as the communities of plants and animals. That includes us humans. The abiotic parts are the non-living components, including sunlight, air, water, temperature, minerals. Each part of an ecosystem is connected to and depends on all the other parts. It takes all the parts interacting in a balanced fashion to make the ecosystem work. Changes to any part of an ecosystem can affect many others, which in turn may affect many more. A healthy, balanced ecosystem provides the needs of the communities of life that are part of the ecosystem. Let's talk about kinds of aquatic ecosystems. Ecosystems are organized around bodies of water when they're aquatic ecosystems. Texas has 6 kinds of aquatic ecosystems. There's aquifers and aquifers and springs, rivers and streams, lakes and ponds, wetlands, bays and estuaries, and the ocean. For Texas, the ocean is the Gulf of Mexico. We're going to take each one of these individually and just provide a short introduction. We'll get into more detail in later lessons. First, let's talk about aquifers and springs. Aquifers are underground reservoirs and rivers of water. The water they contain is called groundwater. Aquifers form where water seeps into the ground over time. Sometimes this water is ancient, having fallen on the land thousands of years ago. Most of Texas's land surface sets over aquifers. Some of these aquifers are large and some are small. About half of the water we use in Texas is pumped from these aquifers by man-made wells drilled deep into the earth. Aquifers need water seeping back into the ground to replenish the water that's pumped or drained out. These areas where water seeps back into the ground are called recharge zones. A recharge zone is defined as the area of land above an aquifer where water soaks back into the ground or travels through cracks or fractures between rocks deep into the earth. Aquifers are very important to the Texas economy, and they are one of the reasons why people are able to live, ranch, and farm throughout the state. Springs are the points where, because of underground geology, springs are the points where groundwater travels to the surface and emerges from the ground. Springs can be a slow seep, or spring water can bubble up in ponds and pools, and sometimes in very, very forceful streams of water. Springs sometimes form the headwaters of streams and rivers. Texas is home to over 3,000 springs, including some of the largest in the United States. Next, let's talk about streams. Rivers and streams are flowing water with a measurable current. The current flows between the stream banks and over an underwater stream bed or riverbed. Now, the word stream can be used to describe all flowing natural waters. Rivers, well, they're just large streams. Streams are ever-changing ecosystems that move and store water. They also move and store sediment and organic matter, such as the leaves or other organic matter, insects and such that fall into the water. Texas has different kinds of streams that vary from one end of the state to the other. Streams have different sizes, shapes, lengths, flow rates, plants, animals, water quality, and stream bed composition. For example, stream beds could be made of rock or made of sand. Regardless of their size, shape, or location, all healthy Texas streams and rivers share a common feature. They are diverse ecosystems. The plants and animals living in them exist in balance with the processes that recycle nutrients or chemicals in the water. These are chemicals and nutrients that organisms need to grow. Now, the healthiest streams are those that flow freely and have natural banks and stream beds. Streams and rivers are also important to people, both ecologically and economically. Streams have been used from the earliest times by humans for travel and commerce. Rivers carry the water humans need for life, and they often are used to carry away our wastes as well. Streams and rivers contain fish. They attract wildlife used by people for food. They're the means by which fresh water is carried to the ocean, and this forms ecologically important wetlands and estuaries all along the way. And they also provide places for recreation important to Texas's economy. This includes paddle sports, fishing, wildlife watching, hunting, and many, many more. Next, cover lakes and ponds. Lakes and ponds are among Texas's most well-known and popular aquatic ecosystems. Lakes and ponds are bodies of standing water, in other words, not flowing water. You may be surprised to learn that Texas actually only has one natural lake. That's Caddo Lake. We'll talk about that in more detail a little later. The many lakes and ponds in Texas have been built by humans by placing dams across rivers or streams. These can range from small ranch and farm ponds of less than the size of a football field to large lakes such as Lake Fork near Dallas and Lake Travis near Austin. The largest of these lakes impounded by dams are usually called reservoirs. There are over 200 major reservoirs and over 5,000 smaller ones in Texas today. Texas lakes and ponds are used to hold water for use by people for drinking, production of electric power, for recreation, for use in agriculture, it would be things like watering crops, for ranch animals. We boat, we fish, we water ski, and we have other outdoor experiences in lakes and reservoirs, and this adds billions of dollars to the state's economy each year as people buy equipment for these experiences and pay to travel and stay at outdoor locations near the reservoirs, near those lakes. Now, small ponds, they're formed by trapping water in valleys or other low spots in a watershed. These ponds are usually shallow enough so that if the water is clear, sunshine can reach the bottom, allowing rooted plants to grow completely across the pond. Pond's water temperature changes with the air temperature. It's about the same from one end to another and from top to bottom. That's because, well, they're pretty small. Not a lot of water in them. Little wave action. The bottom is usually covered with mud. Now lakes are bigger than ponds, so they may be too deep for light to reach the bottom and grow plants much beyond the shoreline. Now while lakes and ponds have much in common, a lake's larger size and greater depth creates differences in the physical and chemical characteristics that are in. This includes changes in dissolved oxygen and the temperature from top to bottom. And we'll cover that in more detail later as well. Next are the wetlands. Wetlands are the in-between places. This is where the water meets the land. These are lands covered with shallow water at least part of the year. They can be present along the edges of rivers or lakes as a transitional zone between uplands and deep water, or wetlands can be individual bodies isolated or connected to other water bodies by groundwater. You can also think of wetlands as giant sponges laid out in the ground. When it rains, these are the places where water collects, and it's held there. The water drains slowly away over time. Wetlands can be big, they can be small, they can be full of tiny floating plants, they can be occupied with massive trees. They're found from mountaintop to the estuary. Near the Gulf, they help form coastal shorelines. They form our marshes, our stream banks, there are swamps. Life in particular gathers around wetlands, and wetlands give life. These are among the most productive ecosystems in the world. Texas has many large and ecologically important wetlands. Coastal wetlands are situated in Texas's estuaries and bays, and up to 90% of Texas's coastal saltwater fish species depend on wetlands for food, for spawning, and places where their young can grow and hatch. Yet these wetlands can have a bad reputation to some people. There are those who think these shallow waters are nothing more than stinky, bug-infested wastelands. Some people even think wetlands should be drained and used for other purposes, but the truth is, healthy wetlands are very important to us. They help maintain our water quality, they recharge our aquifers, they reduce flooding, they provide habitat, and they're great places to go paddling, hunting, fishing, and wildlife watching. Wetlands are dependent on the presence of water for all or part of the time. Because of this, wetlands that do not have water in them year-round can sometimes be difficult to recognize and protect. Sadly, Texas has lost over half of its wetlands. Many have been lost as a result of human alterations such as draining and filling. Many of the wetlands that are left have been partially filled in, some have been polluted, and some have been altered to the point that they no longer function naturally. Taking care of our wetlands that are left and restoring them are among the biggest challenges facing natural resource managers today. Next, let's talk about our bays and estuaries. Although use of the terms estuary and bay are often changed, estuaries are where one or more rivers flow into a partially enclosed area on the coast, mixing fresh water with the ocean's salt water. This mixed water is called brackish. Bays are also partially enclosed by land, but bays open directly to the ocean. A bay's water can be brackish or salt water. Fresh water moves from land to the ocean in various ways. As flowing rivers, as streams, as runoff from land near the coast, and as spring flow from aquifers. At the ocean's edge, these freshwater inflows mix with saltwater to create Texas's many brackish estuaries. Now again, brackish water is a mix of freshwater and saltwater. This freshwater inflow delivers essential nutrients and sediments, along with the freshwater. Salinity is a measure of how much salt is in the water, and it's affected by how much fresh water reaches the coast. Salinity plays a critical role in the health of fish and other coastal plants and wildlife. Too little fresh water allows the estuaries to become too salty for many plants, fish, and wildlife to survive. This dynamic mixing of fresh water and salt water produces nutrient-rich, Dark-colored and turbid waters. These are the waters that feed the estuary and bay habitats on which 90% of all the commercially and recreationally important fish and shellfish of the Gulf of Mexico depend. The mud and sand bottoms of Texas's estuaries and bays are dominated by extensive seagrass beds and benthic communities, including numerous oyster reefs. This essential habitat is being lost. About 60% of our shoreline is eroding away, and almost half of Texas' original wetlands are gone. Coastal barrier islands run along the entire coast. These long, narrow islands block direct flow of fresh water to the ocean. Now, this creates productive estuaries and helps protect bays and shorelines during hurricanes and storm surges. Barrier islands host fascinating, yet sometimes very fragile ecosystems. Next, we'll talk about the ocean, the Gulf of Mexico. The Gulf of Mexico is the 9th largest body in the world. It's like a giant wide-brimmed bowl with the edge full of shallow bays and estuaries. Starting from the coastline and moving out into the ocean, the Gulf has wide and shallow shelves. These gradually slope into the deeper Gulf waters. The floor of the Gulf is mostly a vast expanse of undulating soft mud bottom. The fresh waters that flow into the Gulf greatly affect the health of the aquatic life there. For example, the water flowing from the Mississippi River along the Louisiana coast has created a hypoxic zone, often called a dead zone. This is a vast area deficient in dissolved oxygen where many organisms become stressed or can't survive. This environmental threat comes from excessive nutrients and wastes carried into the Gulf by the Mississippi River. Now, Mississippi collects water from 41% of the continental United States. All these factors combine to support one of the most productive yet ecologically threatened bodies of water in the world. The Gulf is a place of incredible biodiversity with over 15,000 species calling it home. Commercial fisheries annually catch over 1.5 billion pounds of food. Shrimp are the predominant species caught for food for people. Gulf shrimp and oysters account for 70% of all the shrimp and oysters that go into our grocery stores and restaurants across the U.S. Recreational fishing is also important, providing employment and tourist dollars in coastal communities. Over the last 90 years, the Gulf and U.S. coastline has changed dramatically. 50% of our coastal wetlands are gone. Up to 60% of the seagrass beds have been lost, and over 50% of our oyster reefs have disappeared. In Texas, reduced fresh water flowing into estuaries and bays reduces the amount of certain kinds of habitat needed by many of the Gulf's most important species to people and the aquatic ecosystem. Texas's aquatic systems are all connected together. Life in the aquatic ecosystems is constantly progressing toward a state of balance. Balance doesn't mean a lack of change. Ecosystems are always changing. Change comes in response to natural or human-caused events. For example, heavy rains can force a river to change course, leaving the old channel and forming a new one. A human activity such as straightening a stream can speed up erosion and cut out curves in a river that shelter fish and other aquatic life. Changes can destroy habitat for some species and create habitat for others. Whether changes are good or bad depends on how they affect the ecosystem's biodiversity. This term refers to the variety and the number of different species and populations. The more closely the biodiversity in an ecosystem matches that of a completely natural system, the healthier, more sustainable, and better balanced it is. Some human activities that can reduce aquatic biodiversity are things like draining a wetland, damming a river, or pumping so much water out of an aquifer that springs no longer flow. These activities destroy habitat, which is the main cause of species decline. Therefore, protecting and restoring a wide variety of aquatic habitats helps keep species from becoming endangered or extinct.